This is the first problem we are going to solve using Ansys program. And this is your structure, which is actually loaded. And the axial load 150,000 Newton, which is acting at the point of cross section of the two elements. And also the properties of the two elements are given here. The first element is aluminum bar, its cross sectional area, Young's modulus. Similarly, the second element is a steel bar, its area, Young's modulus is also given, and the both supports are fixed supports. And we are going to analyze this structure using the Ansys program, and that means you have to find out the nodal displacement, reaction forces, and also the stresses in the elements, in both elements. Just click on the workbench. Okay, I will explain you how to analyze the structure within the short time. So you have to click on static structural, double click on static structural. So this window will appearing, and go to the engineering data, double click on engineering data, and you will see the default material is given as a structural steel. But our material, let us see what are our materials. So we will see here, yes, these are the two elements. The first element is aluminum bar, second element is steel bar. So you have to enter the properties of these two material. Okay, so I have to add the aluminum bar. So for adding the aluminum bar, again I have to go here, click here. So I will put here aluminum. Okay, just I will put ALU. Then next I have to add the second material. Second material is steel bar actually. So here the default value is steel bar. You can use the same default value, or otherwise if you want to add it, you add it. Okay, so I will place here just steel. Okay, so you have to enter. Okay, now we have added the two material, aluminum and steel. Actually is not required. Actually the default steel is there, but here I added the steel. Okay, so we'll go for the aluminum, and you have to enter the properties of this aluminum bar. So for that one, go to isotropic, and you will see the yellow, two yellow boxes are there. That means you have to enter. It is must to enter these two values. So what's the Young's modulus? Young's modulus value is, see here. Okay, aluminum bar, it is given 70 into 10 to the power 3 Newton per mm square. Okay, so here Young's modulus is given in Pascal. You can change the units, either you can use megapascal or PSI. Okay, I will go for Pascal here. So if it is Pascal, you have to convert that value. So here it is 70 into 10 to the power 3. So if you convert into the Pascal, it will be, you want to convert this one to the Pascal. So you have to multiply with 7 into 10 to the power 3 millimeter square. You have to convert to the meter square. So it will come 1 by 10 to the power minus 6. That means 70 into 10 to the power 9 Newton per meter square. That means this much Pascal. Okay, so enter this value here. So 70 e to the power 9, and Poisson's ratio you have to enter. You can just put 0.3 here. Okay, so this is about the aluminum. And what about the steel? Steel also, how much it is coming? Yeah, 200. Okay, for the steel, again you have to click on isotropic velocity, and you will see the two columns, yellow highlighted columns. Okay, here 200 e to the power 9, and put the Poisson's ratio, it is saying 0.3. So now you entered the two material properties, aluminum and steel as well. Okay, now close. Next you have to go for geometry. In the geometry, you have to provide the length of the elements, cross-sectional area. Okay, so for that one, right click, then click on here. Just wait. So you will see here progress. Yes, so it is open the window. So here I will you can use XY axis, so you can go look at, so it will be XY plane, or you can also change here. Okay, if it is click on this one, it will be 3 dimension. Again, if you click on that, okay, and also you can move your XY plane to anywhere in the screen just by clicking on the pan. Okay, this is a pan, you can move anywhere. Okay, so this is your XY plane now. Now you have to enter the length of the element. That means I have to draw the line. So I have to go for sketching. So in the sketches you will see the line. But to make more comfortable your drawing, you have to go to the settings, and the settings on the grid. And I want the spacing, major grid spacing. Here it is the default 5 milliliter, but actually our all dimensions are millimeter, so it will be comfortable to change the units to millimeter. Okay, so I will change the units to millimeter, and in the millimeter I will change the grid spacing, major grid spacing. I want to make it 100. Okay, so I made 100. That means the each main box, okay, each major boxes will be 100 millimeter line. Now I will draw the line. So go to the draw, click on line, and I will start from origin. Okay, so what's the length of the first element? The length of the first element is 3. Let me see here. So what is the length of the first element? It is 500 millimeter. Okay, so this is your first element. This is 100, 200 and 300, but it is 500. Okay, so 400 and 500. Now it is 500. The first element is 500. Now we can just verify, is it 500 or not. So for that one, go for the dimensions, general, then select your line. Okay, H1. What is H1? It is showing here. H1 is 500, so it's okay. Now you have to draw the second line. So for the second line, you have to go for sketch 2, because the second line is another body with a different property. So go to the sketch 2, by just click on this one, you will get sketch 2, and you have to draw the line. Okay, click on line, and the second element is, what's the length? 800 millimeter length. Okay, so again I have to move here. Okay, so yes, so second element is 800 millimeter. So this is 100, 200, 300, 400, 5, 6, 7, 8, 800. Okay, when you will see here H. Okay, when you see H, it is the line is horizontal. Okay, so when it shows, immediately you can click and you can verify the dimension by click on the second line, and it will be H2. What is H2? 800. Okay, so now you have drawn the two lines, but you have to go to concept. Actually you have drawn on sketch 1 and sketch 2, so you have to make lines from the sketches. For that one, you have to go to the concept, under concepts, lines from sketches, and select the, you have to go to the sketch 1. Okay, so this is your sketch 1, and you have to apply. Then you will see the yellow one here for the line 1. So you have to generate, right click and generate. Okay, So now you created the line from sketches. Now you have to go for the second one. Okay. So again, you have to go for sketch 2, and the sketch 2 line from sketches. I'm sorry, lines from sketches, and you have sketch 2 and just apply. Okay. Now again the same thing. The line 2 is with the yellow one, but before you are going to generate, you have to make it add material. Go to add material and add frozen. Okay, this is very important. You have to make add frozen before generating the second line. Now you added the add frozen. Now you can go for line 2 and right click and then generate. So you will see here now you have two line bodies here. Okay, two line bodies. And now you have to assign the cross section for each line body. For that one, again, you have to go to concept and you have to go to cross section, and you can select rectangular or circular, whatever you like. And what is the cross sectional area? Here in the question, cross sectional area is given. For the aluminum bar, it is 2400 millimeters square. Okay, and for steel bar 800 millimeters. So you can adopt either a circular cross section or rectangular cross section as you like it, but I will use here a rectangular cross section. So what I will do here, okay, I will use a1 is equal to 2400 millimeters square. This is, I will make it as 60 millimeter into 40 millimeter. Okay, that means 2400. And similarly a2, I will change a2 also. a2 is 800 mm square. This 800 mm square, I will make it as I want the 40 mm will be same, so other one will be it will be 20. Okay, so it will be 20 into 40. So I have to go to the concept and cross section, and I am using the rectangular cross section, and width will be 60 millimeter and depth will be 40. Okay, so this is the cross section, and it is showing here rectangle 3 because I will make it a rename rectangle 1. Maybe I deleted the first two cross section, rectangle 1 and rectangle 2, so that's why it is showing. So this is rectangle 1. Okay, now I will go for the cross section. Here I will make it as I will rename 2. So second cross section is we provided, I think, 20 mm and the depth is 40 mm. Okay, so let us see here what is this. Yes, second cross section is 20 into 40. Yes, so we already provided here 20 millimeter width and depth is 40 millimeter. So we already created two rectangles. Now you have to assign these rectangles to the line body. So this is your first line body, and the first line body you have to select. Okay, cross section you have to select. So rectangle 1 I have to select because the first line body is the I think it's aluminum, right? First line body is aluminum and cross section is 60 into 40, right? So this is a rectangle 1 for the first line body, and go to the second line body. Second line body will be the rectangle 2. Yes, now you assign, but you are not seeing the cross section, and before you are going to view the cross section, these two line bodies you have to combine and to make a new part. Okay, now the new part is created. That means one part with the two bodies. Now you want to see the cross section. For that one, go to the view and on the cross section solids. So now you are seeing the cross section. You can see the three-dimensional also the cross section. So this is the cross section of the two elements. Okay, so the geometry is over. Now you have to go for the next step of modeling. So this I will minimize. and then I will go for a model. Double click on the model. Just wait. Show progress is there at the bottom right side. Yes. Here, first you have to go to the geometry and part line body. You have two line bodies. So what is the material for the first line body? It is aluminum. Okay, so select the line body here and go to the material. The material, it is, where is the material? Yes, it is written structural steel. Actually, it is the aluminum. So you have to change the material. Go to aluminum, click on aluminum. Okay, so now the first element is with aluminum. Now second line body, it is steel. So you have to go to the here. Already it is structural steel, but already we created another. Yeah, this one. So select this one. Okay, that's also over. Now you have to go to mesh. Mesh with the yellow bar it is showing. So you have to generate the mesh. So right click and generate mesh. Okay, so now the mesh is generated, and you will see the around is created with the default values. So you can change the element size. Okay, so here how many elements are there? 1 2 3 4 5 6 7 8. Okay, so that means yes, and the next one is 1 2 3 4 5 6 7 8 9 10 11 12 13, and you can change. For example, I want to use the length of each element is 10 millimeter. So 10 e to the power minus 3 because it is in meters. Okay, 10 e to the power minus 3. Then again the mesh with the yellow. So you have to right click and you have to update. So you see here. Oh, now it is each length of the element. Okay, the element size is now it is 10 millimeter. So the length of the first one is 500 millimeter. So you can see here. So it is very small sizes. Actually, we don't require that much. So I will use 50. The length of each element is 50 millimeter. So 50 e to the power minus 3. Okay, so again you have to right click and you have to update. Yes. Okay, so this is 50. The length of each element size is 50 millimeter. So 50, 100, 150, 200, 250, 300, 350, 400, 450, 500. Okay, so the first length 500 mm's length is divided. Okay, to the 10 small elements. Similarly here also you will see. Okay, and now you have to go to static structural and you have to apply the boundary conditions and the load. So right click, insert, and the supports, the two ends are fixed support. So where is a fixed support? Go to the fixed support. Yes, this is a fixed support. Just click on the fixed support and you have to select the points where you are provided the fixed support. So when you select it, make sure you are using the vertex. So this is the vertex, this is the edges, this is a face. So actually this is the axially loaded member. So use the vertex and click apply. You have one more fixed support other end. So again you have to go to static structural, right click and go to fixed support and select the other end. Then you have to apply. Okay. So if you want to see both fixed support at the same time, just click on static structural. You will see the two supports together. Now what is missing? Yes, you have to apply the axial load also. What's the magnitude of the axial load? It is 150,000 Newton is acting. Okay. So yes, here. So go to static structure, right click, insert, you have to apply a force. So where is the force you have to apply? Yes. Here you have to change vector to the components. Okay. So in the components, you will see X, Y, Z components, but actually your load is acting in the X direction towards right. So you have to put the load here 150,000, okay, because the unit is in Newton, and there is no load on Y direction and Z direction, okay. So now you have to select your point. This is the point where the load is acting. Just click on that one and apply. Yes. If your load is acting towards left, you have to put a negative sign here. Instead of positive 150,000, put negative 1,000, and yes, you will see the left side. But in this case, the load is acting towards right, so I have to put the positive. Okay. Again, if you put on static structural, yes, you will see the both fixed support and the load at the same time. And you will see here it is in Newton, 150,000 Newton, and A and B are the fixed support. This is A and this is B, both ends are fixed support. Now everything is finished. Now you have to analyze. So what are the required? So right click on this, go to the insert. We need the deformation, total deformation is required, and also we need beam tool. Go to the beam tool, just click on the beam tool. From the beam tool you will get the direct stresses. This is actually what member, so only the direct stress will be there. And also I need the reaction at the support. So go to the again solution, right click, insert. The reaction is available, or it is a probe. Go to the probe. Under the probe you will see the force reaction. So force reaction, where you need it? You need in the both supports. So fixed support, okay, and again go to the solution, right click, go to the probe, force, and the fixed support 2 also you required. Okay, so now everything is okay. Now you have to go to click on static structural, right click and solve. Wait for a while. It is showing the progress. Okay, now it's okay, the result is ready. Click on total information, you will see the deformation here. Okay, the deformation, please remember the deformation is given in meter. So where is the maximum deformation? Maximum deformation, it is red one. So here is a maximum deformation, and you will see zero deformation. Here is a blue color, that means a fixed support. Fixed support, there is no deformation, it will be zero. And the other end is also fixed support, so here also it will be zero. Okay, now go to the direct stress. Direct stress, you will see a red and blue color. Okay, and here it is given, the unit is in Pascal. Okay, so the red color is a positive sign and the blue color is a negative one. Okay, so red one is subjected to tensile force, the blue one is a compressive, that's why it's a negative value. Then what about the reaction? So this is your reactions. You see here the direction of the reaction towards left, and where is the value? You will see the value here. This is your value. Here you will see the negative sign because it is acting towards left. What about the reaction on other end? Other end is also towards left, so it will be also negative. It is acting the x-axis. So you will see here x-axis reaction is here, written here. Okay, and there is no y-axis and z-axis reaction, that's why it is 0 here. Okay, and one more thing about the deformation. So deformation, if we want the deformation at any required point, just at any point on this element, Okay, you can go to the prop, click on prop. You will see here the deformation at any desired point you can find out. Just click on this one. Okay, so these are the deformation at any desired point. Yes. Okay, so that's all. Thank you very much.